Hi, this is Dr. Vince, the General Surgeon at Fakhr Hospital.
Hi Dr. Vince, how can I help you?
We have a neurosurgical emergency. We don't have any neurosurgeons on the island, and I've never undertaken a neurosurgical procedure.
Could you run me through the triage report?
Yes, 25-year-old male, unhelmeted motorcycle accident, C3 acute fracture, and his CT brain scan shows intracranial blood. He's in the X-ray currently because he has multiple orthopedic injuries.
Okay, what's his level of consciousness, his coma score?
He's currently unconscious, coma score is 8, and he's intubated and ventilated. His left pupil is fixed and dilated.
I think you have to operate there on the island. I can give you a hand.
Scary, isn't it? Doing an operation for the first time, a neurosurgical emergency, with someone's help over the phone. Clear Fog is 4 hours away from Wilford, and such time-critical emergencies should be done in under 2 hours. It's unrealistic to expect remote hospitals to hire expert neurosurgeons. And we can't expect general surgeons to be experts in neurosurgical emergencies. So we need another solution because accidents happen, and we all want to be in good hands in life-threatening situations. Whether a general surgeon or a junior neurosurgeon, it takes a lot of training to become an expert. But do you know how neurosurgeons learn and practice? See one, do one, teach one. That's the conventional method of teaching junior neurosurgeons. They get to practice on cadavers and real patients. Working on cadavers is not cost-effective, and it doesn't allow for repeated practice. Exposure to formalin-containing embalming fluid is also risky, and that takes us to our second option, which is practicing on actual patients. But don't worry, they hardly get a chance in a system that's intolerant of making mistakes. So how can they learn if they don't get the chance to practice? Hi, my name is Roos. I'm a biomedical designer, and I think one of the possible answers to that question is what my research is all about. Multimodal 3D printed neurosurgical training and simulation models. More than 40 years after 3D systems introduced first commercial 3D printer, today we have access to a lot of different machines that can construct a 3D object from a CAD file through a variety of processes in which material is deposited, joined, or solidified through under computer control. Materials such as plastic, liquid, or powder. One of the key characteristics of key advantages of 3D printing is the ability to produce very complex organic shapes that would have been otherwise impossible to construct using any other manufacturing method. So in my research, I'm seeking viable options for combining all these technologies to create a lifelike human head for improving the neurosurgical training experience. I will use specific software to segment different parts of the head and from CT and MRI images and transfer them into a CAD software to design a 3D printer-friendly version of a human head. Most of the parts will be printed on Herstenberg Fabrication Institute's J750 printer, which is capable of printing soft and hard material at the same time. So we can mimic the characteristics of soft and bone tissues. So hopefully by the end of this project, we will be one step closer to manufacturing a hyper-realistic neurosurgical training model with audio, visual, and haptic feedback that junior neurosurgeons and general surgeons could use to for repeated and safe practice and experts could use them to polish their skills and pre-plan neurosurgical, complex neurosurgical approaches. Thank you.